Dampen rates.
There she is. Houston, Aquarius.
Houston, go ahead.
Okay, Vance, a couple of items we uncovered for that cartridge mod. One is the special dust covering bag that we were going to use on the tote bags. That is pretty thick and non-porous. Then we went up to the upstairs kitchen and drained water a couple more times and made up a whole bunch of drink bags again. And from the pantry, we retrieved a fairly large enclosure made of plastic that those drink bags are in, and I think we can scissor and also make do for a cover, taping it on if that's appropriate.
Okay, Jack Lausma here has a refined version of the procedure on how to make these the easy way, and I think before too long he ought to be reading that up to you. It's not time critical to get this up to you. It's just that before you get too far in assembling these on your own, we'd kind of like to give you the benefit of experience down here.
Okay. Who built them back there?
Tony did some of it, and Jack's been working on it too, so we've had a big effort on it.
Great.
We would encourage you to wait till tomorrow to receive that procedure, but we can send it up sooner if you insist. Over.
No, that's all right, Vance. Well, we have to worry about that. I guess we got another primary and 3 secondaries to go through.
That's right.
Sometimes those cartridges have they rejuvenate.
Aquarius, Houston, over.
Man, that's a wicked low pressure down there.
I wish I was in it.
Aquarius, Houston.
Go ahead, Houston.
Okay, Jim, your rates are once again looking good, so we can continue on and with the rest of this procedure. Request you go ahead with the verb 76 enter and mode control to add hold, and then the last step 30 clicks yaw right.
Jets are firing again.
Okay, I'll go verb 76 center with the mode control add hold, and then 30 clicks of right yaw to start the maneuver.
Verb 76 enter.
Roger. There's your verb 76 enter. Mode controls and add hold. Now you want me to do the 30 clicks of right yaw? Did you say for me to hold on the right yaw, or do you want me to start it now?
No need to hesitate. You can start now.
Okay.
After you get that going, then we'll think about powering down the pings.
Okay, there were 30 clicks of right yaw.
Okay, we'd like to look at it for just a little while before we power down the pings, so stand by.
Understand you're planning to power down the pings.
All right, we want to get the amps down.
Let me shoot a picture.
Hey, what do you take pictures for?
Why not? You want to bring all the film back onto. I locked it this far, I'm going to shoot it. Every last lousy one of them.
Well, that means I've got to, hey, let me see if I can see stars.
Can you?
Yeah, I thought I could there for a while.
Where's Houston? Request aft Omni.
You got it, Van?
Raj, that did it. Thank you.
Yeah, there's Solomaias and Alphonsus. Yep, they're not. See them right over the edge. Shoot a few pictures of the old moon again.
Yeah. Well, what's the flood torch? Put it back?
Yeah.
Looks like we've got to do with Earth sun alignment.
We need it to align again.
You don't think that burn was enough, do you? Is that a big course?
An RCS squirt.
Yeah. An RCS score needs an attitude.
Well, and here ought to come up the sun. Yeah, you got us in the right plane, Jim. We're in the right plane. We're pointed north, and we're swiveling again with Earth, Moon, and Sun.
Well, in that respect, it might be easy to get a...
It's Apollo Control, Houston, 81 hours, 45 minutes now into the flight. Apollo 13, presently 11,587 nautical miles away from the moon and traveling at a velocity of 4,600 feet per second.
Oh, that's right. That blasted service command module back there. But that one. That one.
It's not much better. Wait a second, what's all this?
Keep quiet by the
Aquarius, Houston, over.
Go ahead.
Jim, we have some status information for you if you're ready to copy on a piece of scratch paper.
Stand by, man.
Okay.
What are you looking for? Putting that away and getting the status paper here.
Go ahead, Vance.
Okay, first mid-course correction will probably be at GET 104 hours, and all we look for is a 4 to 6 feet per second, delta V. Okay, that's the first item. Now I will give you a rundown on consumables. Okay, in the LEM, you have 1,498, that is 1498 amp hours remaining. That means over 61 hours, that would average out to 24.5 amps. We expect after power down that you will use 14 or 14 amps per hour, and that would leave a reserve of 500 amp hours at the end of the mission. Are you with me?
Well, through with you.
I tell you my number was yesterday.
Okay, in the LEM you have, Raj, in the LEM you have 215, that is 215 pounds of water usable. That would average out over 61 hours to 3.5 pounds per hour available. Okay. Okay, and after you power down, we expect that you will be using water at the rate of 3.2 to 2.7 pounds. That's at 14 amps per hour electrical usage rate. One note, this does not, when we speak here of water available, this does not include CSM water and Pliss water. So that's added on. Okay, next, LIOH. Using the CSM cans, you will have 16 cans at 12 hours per can to give you 192 or 192 hours of LIOH. And in the LEM, using its cans, you have 44 hours remaining.
Vance, is that with the Pliss secondaries?
That's a firm. That's a firm. That includes Pliss secondaries. Okay, oxygen. You have remaining 44 pounds in the LEM. At a usage rate of 0.36 pounds per hour, that leaves you 120 or 120 hours of oxygen. Okay, next RCS. RCS-A stands at 62% and B at 62%. We only expect 2% to be used for the PTC, so you're in good shape for RCS. Next, dips delta V. You have 1190 feet per second remaining. And finally, CSM, EPS, that's, we estimate that you have 99 amp hours. That's an estimate. And that's it. Over.
Okay, I copy.
Okay, and just a question. Be interesting to hear from Jack to see if he thinks that main B bus is good. If he has any idea of whether it's good or not, this would influence our steps in the future. For example, we might want to try to test main B to see if it is in fact good, so that we'd know how to set switches for entry.
Raj, just a minute. They want to know whether you think main bus B is any good for the man muscle. While Jack's get on the loop, let me pose a question of how we're planning on doing this discourse if we're going to power down the tanks.
Would you stand by on that, Jim? We'd like to give you a procedure for that later on.
Okay. Mid-course at 104 hours. Going to give you a procedure for that later on.
In short, Jim, we don't expect any problem, but we'll explain further later on.
Okay.
Deke says get a night's sleep. He says you've been working hard, and you ought to relax a little bit and be ready for tomorrow.
Vance, this is Jack.
Go ahead, Jack.
Okay, let me give you my observations on main bus B. Things happen pretty fast there, and we first heard the impact or explosion or whatever caused it. I'm not sure. The next, about 1 second later, there was a master alarm, which was a main bus B undervolt. I looked at the voltage, and the voltage was good at this time, so I'm suspecting it was a spike. Fuel cell 3 was also good, with good flow. However, Fred, at that point, was coming into the command module and got over into his seat. At that time, we certainly had an AC bus 2 light. About the time he got in his seat, he looked at main bus B, and the main bus B was reading 0. However, and the fuel cell flows were 0. I'm kind of suspecting that perhaps we do have a good main bus B, but that's merely a guess. I never did try to reset it. We were having other problems with main bus A having an undervolt and a few other things like that. I'd kind of like to hear what your feelings are down there.
Well, Jack, we copy your information, and we'd like to hold off because we're still working the problem. So we will have to give you information later. Thank you. Aquarius request aft Omni. Raj, we're with you.
Okay, we lost luck there and we switched omnis. Just for my own kind of to get my thoughts in order, I kind of I'd like to hear what kind of entry you're planning, EMS or pings or what.
Okay, ping's entry is being planned, and people are at work on checklist changes and that sort of thing.
Okay, real fine.
And we'll give you the CSM stuff tomorrow, but basically we suspect that main bus B is good, and we're going to work up a procedure to test it.
Okay, those are my thoughts too.
Roger.
You think main bus B is good, don't you?
That's a firm, we think it is, but we want to check it out anyway.
Hey, we think you guys are in great shape all the way around. Why don't you quit worrying and go to sleep?
Oh, that's our boss. Beach.
Well, I think we just might do that. Or part of us will.
I mixed up. How many more of those are we? Hot mic?
Yeah.
Yeah, I mixed up. You had 15, I mixed up 7 more, so we got 22. By the way, there's still some water. It's not enough pressure to mix up another drink, but there is some water out of there if you want to get some water out of the drink gun.
Yeah, it's good. Good one.
We ought to use that oxygen up, not waste it.
You monitoring right now?
Yeah.
Just stand by there.
Yeah. I will. You wouldn't believe it, but I'm now in command of the lift. Okay. Vance, I'm probably the only CMP that's ever witnessed dips burn sitting on the SN engine kit. Did you get them? Is there any coming out still? They didn't answer. I think we may have. How is this working out? They are. How are we going to get in alignment?
Maybe we gotta watch that one right there.
It's decreasing now. It's a cone. I noticed in the command module. It'll wobble. switch on these threads now.
Houston, Aquarius.
Go ahead, Aquarius.
Raj, you're planning to set up here very shortly a power down procedure?
That's affirmative. If you'll take out your contingency book and turn to page power 6, over.
Roger, stand by. Contingency power 6. Get the book over there, contingency power 6. Thank you.
And while you're doing that, let's put attitude control, 3 switches to mode control.
All 3 attitude control switches have been in mode control.
Okay, and when you get to power 6, you ought to see a circuit breaker page, panel 11. Okay, on power 6, panel 11.
Take the slide out.
The top 3 rows, configure them as you see them.
Okay, now, Jack, some of them have changed now that we have put the TCAs in from a previous procedure. Did you want those out now?
That's affirmative, Jim. Pull them out. TCA's open.
Okay. I'm changing those. Get back again. First 3 rows. And you're including the Atka pings, huh?
That's affirmative. Pull Atka pings open.
Okay. I got that.
Okay, are you ready for the 4th row?
Affirm.
Okay, now and when we get in the 4th row, we're going to open the IMU operate circuit breaker. And what that means is that we're going to lose the capability to watch your CDUs. So we're not going to be able to see your attitude. Therefore, we will not be able to advise you on which antenna to select for communications. The way we want you to handle that is to turn the LEM uplink squelch off, and when you hear the noise, switch antennas. We'll be able to see you switch antennas, and it's going to take us about 3 to 5 minutes to establish a lock-on again after you switch. After each time that you switch antennas, we will initiate a voice check. Basically, when you see the Earth out the window, you can be on the forward antenna, and when the moon's out in the window, use the aft antenna. You copy?
That's Jack Klausma now in the capsule communicator position.
We're going to pull the IMU operating circuit breakers. You won't be able to see our attitudes. Therefore, you won't tell us how to switch antennas, and we'll enable the, I will turn the squelch off so that when we start getting static, we'll switch antennas. And as a some rule we can use with the Earth forward, we use the forward antenna. And when we see the moon, we use the aft antenna.
That's affirmative, Jim. In other words, we're leaving antenna switching up to you. And after you switch antennas, it's going to take 3 to 5 minutes for us to establish a lock-on again, and we'll initiate a voice check. And I'm ready to go on panel 11, row 4.
Okay.
Okay, on row 4, under heaters, RCS system AB-1, open quads 1 through 4. Under ECS, the only change is
Under glycol pumps, close, auto transfer. Under COM, the only change is open VHFA receiver, open commander audio. Under pings, the only change is close and leave closed IMU standby circuit breaker so we can have heaters. Read back.
Okay, on row 4, we're going to open all 4 of the heaters of the RCS system A and B, the first 4 circuit breakers. We're going to close the auto transfer. We're going to open the VHFA receiver and the commander audio. And we're going to close the IMU standby. The LGC Disky and the IMU operating will be open.
That's affirmative, Jim. All other breakers in that row are as you see them in the checklist. And on row 5, the only change is that we want you to, under EPS, open Ascent ECA control. Over.
Right, I think we already have that opened. Ascent ECA control is probably already open. Okay, so let me confirm. We'll have one comm system. That'll be the LMP system. And we'll have to do our own antenna switching. Therefore, we'll have to wait about... okay, you want to switch after antenna. Well, I have to wait for you to get a lock on again. Is that correct?
That's affirmative, Jim. You'll be working off of the LMP's panel over there.
Okay, what else do you have for me?
Okay, panel 16, that's on page power-7. Top row, the only change is under RCS System B, open PQGS displays. Over.
Okay, let me go over this with you, Jack, because this checklist has been written over 2 or 3 times now on our various procedures. Top row, the first 2 are open, the next 3 are closed. And we're going to open now the quad PCAs 1, 2, 3, 4. Cross B will be closed. And the dim fresh display flags will be open, and we're going to open up the PQGS. Main size will be closed, so all the other 3 will be open.
That's affirmative, Jim. And there's no change to the second row. Over.
Okay, again, let me go through this with you. The first 4 are going to be closed. The next 8 will be, the next 9 will be opened from logic power B through descent engine override. How about the Sealy? Is that going to be closed?
That's affirmative, Jim. We want the next 5 closed.
Okay.
Okay, in the third row, under COM, displays open, SE audio closed. VHF-A transmitter open, that's a change. VHF-B receiver open. Primary S-band, power amplifier open. Transmitter receiver closed. S-band antenna open. PMP closed. TV open. Under ECS, displays, open. Glycol pump secondary, open. LGC pump, open. Cabin fan control, open. Cabin repress closed, and all the next 4 closed also. Read back.
Okay, we have displays open, SC audio closed, HMA transmitter open, HFD receiver open, power amp's going to be open, transmitter receiver closed, S-band antenna open, PMB closed, TV open, display is open, next 3 are open, cabin repress closed, and all the rest closed.
That's affirmative, Jim. And in row 4, under heaters, we want them all, correction, we want all the quad heaters open. Correction, we want all the quad heaters closed. We want displays open. S-band antenna closed to avoid a master alarm. Camera, sequence camera open. And under EPS, we want displays open. DC bus volt closed. Inverter 2 open. Ascent ECA closed. Ascent ECA control open. Descent ECA closed. Descent ECA control closed. Translunar bus tie closed. We want the cross tie bus open. The bell loads closed. Bat feed ties closed. How do you read?
Okay, the 4 RCS heaters will be closed. Displays open, S-band antenna closed. Camera sequence will be open. Display will be open. DC bus volt will be closed. Inverter 2 open. Ascent ECA will be closed, but the Ascent ECA control open. Descent ECA closed. Descent ECA control closed. Transmitter bus tie closed. And cross tie bus open and ballast loads closed and the bat feed ties closed. I have one question, Jack. On panel of the second line, they're under lighting. Why are we keeping the plug and track closed? Are they going to be open?
Negative, we have the lighting breakers all closed. Control the lighting with the switches and the rheostats, over.
Okay, we don't need the floodlights, I don't think, but we can do it that way, I guess.
And we haven't used under row 4, under RCS system A and B-2 quad heaters, you notice that we've closed those circuit breakers, but what we want you to do is to, on panel 3, turn the RCS AB-2 quad switches 1, 2, 3, and 4 off. Over. And we're going to watch your quad temps for you, and when we need to warm them up a little bit, we'll tell you to throw those 4 switches on panel 3.
Okay, now are we sure that this PTC mode is good enough so we don't start getting cross-coupling and get out of configuration?
Stand by one on that, Jim. Okay, Jim, as far as we can tell right now, the PTC looks as good as any PTC we've ever seen in the CSM, so we're going to go with what we've got. Okay, and if you turn over the page in Power 8, we have the spacecraft functions remaining to you. We've got low bit rate TM. However, we don't have any VHF. We have SeaWee. We have glycol pumps. We have suit fans. We have cabin repress for you. And standby and attitude control here. Okay, in attitude control, we'll have hardovers for use as an emergency. And for normal usage, we want to have a 15-minute delay to get the heaters on to warm them up before use. How do you read?
Okay, for emergency, we have the hardovers, and for normal use, requires a 15-minute request to get the heaters on.
That's affirmative. Okay, Jim, that concludes our power down procedure. We're waiting for you to get with it.
Okay, Jack, we'll start. I sure hate to lose the tanks. And I sure hope that procedure for the mid-course is a good one.
It is.
You want me to help you?
Yeah, you can. Okay, emergency power down. 10, 11. All of them open. Close.
Yeah. Under your count. And it works about under your knee on the floor.
Stand by for mass alarm. Oh, yeah. Here it comes. Hit it.
LGT, you just did it.
I'll give you this when I'm finished. Let me go through this, and then you go through it again and double check it.
Now the floodlights are on, right? No, I kind of don't think we need to look.
Go pull those. Give me the, first of all, we'll get back there. Those four are closed. Open. Open. Engine arm. Open. Zero. Second thing. Fourth stage. Deck egg. Good job. Play. Test the audio. Say, Houston, Aquarius.
Go ahead, Aquarius.
Take him a minute to
You're familiar with our particular spacecraft that on panel 16 under heaters, RCS System A and B, Quad 1, the heater circuit breaker, has been pushed in and sealed in, but if it's ever pushed out, its download will ever be able to reset it.
Okay, Jim, on the 4 quad heater breakers, we want you to leave them closed. And we'll operate the heaters with the switches on panel 3, over.
Okay. No. Okay, and I'm closing the heaters on panel 4, quads 1 through 4 off.
Okay, and it's time for you guys to get to bed and get Fred up.
I still have one question, Jack. I still think that the under lighting on panel 16, the floodlights and the track lights should be open. We're not using them.
Do you have any argument?
No problem, Jim. Go ahead and open them. Track and flood, that's all right.
Okay. Track and flood are open.
Now, why don't you go through that, Jack, and make sure that I had it.
Okay, I'll take this.
Okay, and Jack, my only other concern now is the CO2 rise of the spacecraft. I guess you're keeping a handle on that?
That's affirmed, Jim. We have you up to 10.6 now, and we're willing to go a little higher on that. We have another cartridge, and we have a procedure for making the command module cartridges up. We'll pass that on later.
All right. Yeah, I'm not worried about that. I just want to make sure that you,
Are they going to...
we just don't want to go to sleep here and forget about the rise in CO2.
Are they going to use...
Roger, we're watching it for you. We have it here. It's now 10.7, and we have a medical go to 15 millimeters.
That's the new one. There's the new first for you.
Okay, Jim, we estimate we've got 1 more hour on the primary cartridge and 6 or 7 hours on the secondary.
Okay, fine. That's a spare primary cartridge back there too, isn't it? So that's good for another, how long?
You're right, Jim. We got another primary cartridge back there behind the S and engine cover.
Right, yeah, we know. Thank you.
Okay, I guess you've done everything right.
Hey, Jack, we just thought it's about time you got a limb checkout.
But he's given it me inert. Of course, I'll give him my command module, too, which is rather inert right now, too.
Well, you got to walk before you run, you know.
This is Apollo Control at 82 hours 30 minutes. Here in Mission Control at this time, we're in the process of completing a shift change. Flight Director Milton Wendler and his maroon team of flight controllers replacing Flight Director Gene Kranz and the white team. On board the spacecraft, the flight plan calls for the two of the crewmen, Commander Jim Lovell and Command Module Pilot Jack Swigert, to begin a 5-hour rest period shortly. All three crewmen are scheduled to be eating at this time, or to have finished by now. The lunar module has been essentially powered down, and at the present time we're showing a total current on the lunar module ranging between 14 and 15 or 16 amps, which is about what was expected.
Aquarius, Houston. Aquarius, Houston, over.
Go ahead, Jack.
Roger, for your information,
You're
Jack, all of our analysis is based on power down to 14 amps, but we're reading on you right now 12.3, and so we're better off than we were in our analysis.
That sounds good. Jack, I thought you were going to get the sleep shift where there wasn't any excitement.
Well, I tried, but I didn't make it. I thought you're supposed to be sleeping now.
Well, Fredo is getting something to eat, and Jim is starting to stack out, so I'm taking the con here till Fred gets done.
Okay.
That was Jack Swigert reporting that Jim Lovell at the present time is resting. Fred Haise is getting something to eat, and when Fred finishes eating, Jack Swigert is scheduled to get a bit of rest.
Are you ready to take over? Boy, he just asked that I thought I was supposed to be asleep. I told him that I was waiting for you to... Okay, you were off the net when he forward to tell when to switch antennas, so that just when they can see a switch, it'll take you a couple minutes for them to get up. And they'll always make a voice check with you. It came out here, I caught it. Okay, you get squared away, I'll give you the con here. I don't know. Right, close to 150. Well, they're showing right now 12.3 amps. Their analysis is based on 14, so they're okay, Hanson's here.
Hearing you loud and clear, Fred. How many?
Okay.
Okay, I heard...
you luck out with all the good ships.
Yeah, I got all the good deals. I heard Jack brief you on the comm mode, so you got any questions about that?
Okay.
And how's your PTC going? I heard Jack tell you we can't see your CDUs. How's it going?
Well, let's see. We may be offsetting slightly. The sun looks like it may be a little higher. I'll have to wait. Now here comes the Earth by, and it looks from out between perspective. I'll have to wait and see the moon on the other side, Jake. Let's do forward on me now.
Okay, Fred, I can't hear you anymore in kind of background noise. I assume that, I think I heard Jack tell you what we're going to do about comm. Uplink squelch off. You'll take care of the antennas because we can't see your attitude. We'll give you a voice check when we come up. It'll take us 3 to 5 minutes to come up. And to make it astronaut proof, when you see the Earth, use a forward antenna. When you see the moon, use the aft one.
Yeah, that's pretty straightforward. Okay, I see the Earth, so I've very wisely shifted to forward.
Good boy.
Battery, I think. Really thick. Earth will be by over there in a minute. Jack, you still there?
Still here, Fred.
Okay, when I was upstairs just a minute ago, I noticed what appeared to be some new venting from down the service module way. I noticed it out window 1, and also saw one chunk of metal, loose metal, about 4 inches square that was tumbling around, silver in color. It looked looked like it had come from somewhere down in the service module.
Okay, you saw some bending out window one?
Right.
Go ahead.
Yeah, that's where when I happened to be looking, the lighting reception that showed up past there, and what reminded me of it was I'm looking out the limb window now, and I see a good part of the new star field that's created for us. Just about 1,000 little sparklies out here.
Okay, so you're seeing some bending out window one, and you saw a 4-inch square piece of loose metal, which was silver, and are you still seeing the bending, or has it zeroed out now?
I don't know. I left upstairs. I'm down on the limb now, Jack. I guess Jack goes up. He can take a look and let me know. Okay, I'll think about switching the aft here directly. I see the moon, and the moon looks pretty good, Jack. So I guess our PTC still doing pretty good.
Okay, and we won't have any comm delay if PTC stays good.
Yeah, sure enough, the moon is getting smaller.
Good, and we want to ask you another question about the venting. Is this, would you suppose, some new venting, or is this venting that you just hadn't, that's been going on all the time, but which you hadn't looked at recently?
I can't really say, Jack. We've been so tied up down on the limb, I guess we kind of forgot about the other half. But I'd been upstairs several times and hadn't particularly noticed any flow by the windows before, so my first assumption was that it was some new venting. It really wasn't very heavy.
Okay, copy, thank you.
And Jack's going up to take a look now.
Okay. And for your information, all of our numbers are based on amperage usage of 14 amps. And we're using only 12.3, so we're a little fat on our analysis.
Very good. It's the way to be.
And we're in
I'll tell you, this Aquarius has really been a winner.
Well, that's one of several, and we want to tell you something that I told Jim earlier, and that concerns control. Right now, you have control in hard over if you need it, but when we go to some normal control mode, since we have the quad heaters off, we want to have a 15-minute notice for attitude control request. Over.
Okay, Jack, offhand, I can't imagine, since we got the platform powered down, why we need to worry about any instantaneous control. But at any rate, we need 15 minutes warm up with the heaters before we can start using thrusters.
Right, and another thing we've done is to pull your ECS and EPS display breakers, and but we've left your caution and warning powered up. So if you get ECS type or EPS caution and warning, you have to power up those meters with the display breakers. And we are watching for you, your PIPA temperatures, your ASA temp, your propellant temperatures except for the dips propellant, and we're watching your quad temps for you.
Okay, that's very good, Jack. You're watching them, that's good enough.
And everybody's fine at home now, Lago.
Great.
And Fred, your CO2 is building up. It's at 11.3 on our gauge, and we've got a medical go up to 15 millimeters, at which time we'll switch over to secondary. Looks like we've got plenty of lithium hydroxide, about 192 hours, including the CSM cartridges, and as you know, we've got a way to use those, and as soon as we get it written down in some good words, why we'll pass that along. You might be able to make one.
Okay. Yeah, we'll sure give her a try. And I'm showing on board about 12 and a half millimeters of mercury.
Roger, and I have a flight plan update. When you get a time to copy it sometime, we'll pass it along. There's no hurry on it.
Okay, stand by one, Jack. Back down. Last one. Okay, Jack just came back and he said it's still coming out. It's coming out only on the commander's side. So he saw it out the same window I did, window 1. And it's between the minus Y and minus Z axis.
Okay, and of course,
it's definitely a service module, which was my impression too.
okay, so you're sure it's a service module, and of course the thing we're interested in knowing, is it something that is residual from before, or is it something new? And if you have any ideas about that, why we'd sure like to have them.
Jack, and I'll ask you your question in a minute, but Big Jack's first impression here is that it's not near the intensity that it was right after our mishap, and I'd have to agree with that. I'd say he says it's half, and I'd say maybe even down to a third. And Houston, I'd like to know, do you have any impressions as to whether it's still residual from that, or maybe something new? I don't know why, if I felt that. Yeah, I felt it was something new maybe too. Okay, switching forward on me.
And Fredo, if you think it's practical, we're ready to give you some, or we're working on some camera settings for pictures of the venting. And if you have a camera out and ready to go, let us know which one it is, so we can get settings for that camera. What do you think about that?
Okay, Jack's got one with a 250 millimeter lens on it, that's a standard EL, and I have a surface camera out that I've been shooting hundreds of Earth moon pictures with, camera 1, and we also have the Roseau upstairs that's pretty handy, the command module DC camera.
Okay, and I copy the...
Take your choice of those.
I copy the 250 millimeter. The Roseau is available, but I didn't get what other one is.
Okay, I got my Hasselblad surface camera down on a limb here, handy too, camera 1. Jack, if we're going to do any picture taking out the command module windows, I think we ought to do that either pretty quick or hold up till Jim and Jack get their rest done.
And we concur with that. Okay, Fred, we're not going to bother the skipper up there. We won't be taking any pictures out of the command module window until after rest period.
Okay.
This is Apollo Control at 83 hours, 2 minutes. Fred Haise has the watch at the present time in the command or in the lunar module rather, while Jim Lovell and Jack Swigert attempt to get some rest in the command module. The flight plan calls for a 5-hour rest period for both the commander and the command module pilot. Recapping briefly, Fred Haise remarks after coming back to the LEM from the command module where he'd been getting something to eat. Fred reported that he'd observed some venting, apparently from the service module, and had also seen a 4-inch square piece of metal, which he described as silver in color, float by the window of the command module. He was looking out the number 1 window, which is the viewed from inside the command module, is the window to the left of the commander's couch, the far left window. Haise was asked if he felt the venting was something new or if it was residual venting from the original event which had caused the loss of power and oxygen to the service module. He did not know, and we also have not determined here on the ground whether this is an event associated with the original loss of power from the service module or whether it is something new. And that's being evaluated at this time. Haise said he did feel definitely that the event was coming from the service module, that the piece of metal that he'd seen float by was from the service module, and that the venting was from the service module. Flight Director Milton Wendler, after reviewing the situation, elected to wait until after the commander, Jim Lovell, and command module pilot Jack Swigert had completed their rest period before attempting to get back into the command module and photograph the venting and whatever pieces might be visible out the window. This is Apollo Control at 83 hours, 11 minutes. A change of shift press briefing is being planned to begin in about 10 minutes at 12:35 a.m. in the main auditorium at the Houston News Center. The participants in the press conference will be Flight Team Flight Director Gene Kranz and astronaut Tony England. And repeating, the time for that change of shift briefing is tentatively planned for 12:35 a.m., about 10 minutes from now.